Richard Feynman was a Nobel Prize-winning physicist, and he tells a story about going into the mathematics department and challenging anyone there to explain to him any idea, no matter how difficult or complicated. And as long as they used simple terminology, so no complicated words or terms that he didn't understand, they explained it to him in a way that he could understand, he would reach the same conclusions that they did, and they were studying this material. Now, this story is often brought up to show what a great genius Richard Feynman was, that he was able to do this. But in reality, anyone can do this technique to learn anything, and I'm going to show you how to do it. You can use the Feynman technique to understand ideas that you don't really get. You can use the technique to remember ideas better that you understand but you can't remember perfectly for tests. Finally, you can use this approach as a really efficient way to study before an exam. So a lot of students will spend hours cramming in a library to not that great results. You can use this technique in 20 minutes to deeply understand an idea that will stick with you for years. So let's walk through the Feynman technique so you can apply this in your own studies to learn better. The first step is to choose the concept you want to understand. Take a blank piece of paper and write the name of that concept at the top of the paper. The second step is to explain the idea to yourself as if you were teaching it to someone who did not understand it at all. This is crucial because in explaining to yourself already the ideas you understand, as well as the ones you don't understand perfectly, you gain a better understanding and it helps you pinpoint exactly the things you don't understand. Whenever you get stuck, go back to the reference materials, lectures, or a teacher assistant and reread or relearn the material until you get it enough that you can explain it on the paper. Finally, wherever you write down a wordy or confusing explanation for something, try to either simplify the language or create an analogy to understand it better. You'll notice I used both of these in this quick demonstration. I simplified the language of torque to explain it in terms of twisting. Second, I was able to understand it through analogy by taking the torque vector and describing it as a corkscrew motion, tightening with right or loosening with left. Here are some examples of this technique that I used in an actual class learning physics. Now, you can use this technique for understanding mathematical or technical classes, carefully walking through these steps and explaining to yourself. But you can also use this technique on non-technical classes to understand big ideas or even to put together a large amount of facts or concepts into the same place so you can understand them and remember them in the same context. So how can you use this technique? Well, if you're trying to understand an idea, you can walk through this technique very slowly to pinpoint exactly what you don't understand. So you can go to the textbook or a teacher or your old lecture notes to figure out exactly the concept you're missing. If you're trying to remember the idea better for tests, then you can go through the idea and focus on creating better analogies or simplifying the words of your explanations even more so you can understand it more vividly. Finally, if you want to use this technique to study for tests, then you can go through the technique without looking at your reference materials at any point. That's a really good way to self-test to see if you understand the ideas deeply, because if you can go through it all and explain it deeply without referencing textbook material, then you understand the idea at a deep level. So go use this technique right now. Take out a blank piece of paper and write down a topic that you're trying to understand or study for and go through it. It'll only take 15 minutes, but if you get in the habit of using this technique, it's a very efficient way to learn and study new material.